Chapter 1, Section 3, using the midpoint and distance formula. Today we're going to look specifically at the midpoint and how we discovered that. So the first thing, definition-wise, we have two definitions at the very beginning. We have midpoint and segment bisector. So these two up here. And then the midpoint is a point that divides or bisects, basically, the segment into two congruent segments. And remember our symbol for congruent we wrote here had a equal sign with a little tilde on top, or a little squiggly on top, I mean. And it means the same. So two segments that are exactly the same. And then segment bisector is a point, ray, line segment, or plane. So it can be any of these, keep that in mind, that intersects the segment at its midpoint. So we'll look into that. The first example that I have on here, or thought, is discovering the midpoint formula, and then their question was, what if the points were on a line, a number line, like P was located at 2 and Q was located at 8, where would M be located, and M being the midpoint. So if we go ahead and draw in a number line here, okay, and I'm going to go ahead and start at 0 because that's how most number lines are, and I'm going to shift it over to this side. So normally you might have 0 in the middle and then you go from there, but I don't need the other side, so I'm going to go ahead and start at 0 on the very end because all I'm concerned about is these counting up. So 1, 2, 3, 4, 6, 7, 8, 9. And you want to try to make them equal spaced. It's a little bit difficult to do with my stylus. So we have a couple points located on here. We have a point that's located on 2, so 0, 1, 2. So a point here, and that point is point P. And then we have Q located at 8, 3, 4, 5, 6, 7, 8. And we have point Q located here. And then where would the midpoint be? Now we can do this a couple ways. First of all, you can just look at it and you can kind of tell. But a way to make sure that we actually have the midpoint would be to count from each side. So there's 1 from each side, there's 2 from each side, and then there's 3 on each side. And therefore my midpoint is going to be at this point right here. So I have a point M that I can label, which is the midpoint, and I know it is because I counted from each side. Our first true example, we're looking at the diagram number 1, and we're looking at the skateboard, I believe it is. Yeah, skateboard design. So we have a skateboard design, and we're looking at VW. So segment VW right here is going to bisect XY. So XY being our extended point here at point T, which is in the middle. And then XT, so I'm going to go ahead and label this. XT is 39.9, and then they want you to find XY. So we're trying to find this total length here. I'll put it in a different color so you can see it a little better. And we know one of the segments. And remember, if we have a bisector bisects it at the midpoint. So up here, we're bisecting at the midpoint, and whenever we bisect something at the midpoint, it divides it evenly. So then we know that this other one, TY, is 39.9 as well. So then if we do our segment addition, we have XY equals, and then in this case, XY equals XT plus TY. We're looking for XY. XT we said was 39.9 centimeters plus TY, which we said was the exact same, 39.9 centimeters. Therefore, XY must be 39.9 plus 39.9, which is 79.8 centimeters. So, looking at our second example and diagram 2, and example number 2, we have point M is the midpoint of VW. Find the length of VW. So if I was doing this normally, I would say, okay, our total length, which is VW, which is VW, equals VM plus MW. And now if we actually look at this and we solve for this, Well, we don't know what VW is, and we know VM is 4x minus 1, and MW is 3x plus 3. So we have that, but that really doesn't help us any. So we need something else, something that's going to allow us to solve for VM. And if we look at this, we can see that VM equals MW. So I could set these equal to one another. So I could say VM segment equals MW. And now when I plug it in, I get 4x minus 1 equals 3x plus 3. So now I can go ahead and solve for this. So if I want to move the negative 3x, I need to subtract 3x. So minus 3x on both sides. Whatever I do to one side, I must do to the other side. So I have 4x minus 3x, which is just x. So I get x minus 1 equals 3. I need to move the 1 over to the other side of the equation. So I want to undo a subtraction. So I'm going to add 1 to both sides. So 1 plus a negative 1 is 0, which just leaves me x on this side equals 3 plus 1, which is 4. So x equals 4. So now if I want to figure out how long VM is, then all I have to do is take this and plug it into the original equation. So then I get 4 times 4 minus 1. Which then this equals, so VM equals 4 times 4 minus 1, which is 16, minus 1, which is 15. And we don't have any units, so 15 is my answer. Okay, so we're going to do some guided practice. I went ahead and wrote it down before I was talking, so that way it will save some time. But go ahead and pause this and write it down and then start the video. So identify the segment bisector of PQ. So figure out what the segment bisector is, and then after you've done that, find what PQ is. So hopefully you went through and you did the work associated with this. A couple of the key points for this. First of all, the bisector is L, so line L, because we don't have another point to label it by. And then I set I set PM and MQ equal to one another, so across the equal sign. And then I solved for x. Once I found what x was, then I subbed x back in, knowing that PQ equals PM plus MQ. And therefore I got for my total answer 11.7. If you left this in a mixed fraction number, I'm okay with that. I'm going to have to go talk to some people, because in science, we would just write this as a decimal. But in math, sometimes they do things a little different. So I'll have to figure that one out later. Okay, the last thing we're going to do on this video is look at the midpoint formula. So we're going to look at midpoints and how we find midpoints. So the midpoint formula, the coordinates of the midpoint of a segment are the averages of the x. So let's go ahead and underline that because that's important. The averages of the x coordinate and then the averages of the y coordinates of the endpoints. So we're looking at averaging x coordinates, averaging y coordinates. And the way this looks, so I'm going to go ahead and take mine and make mine a little bit bigger. I would suggest that you put yours off to the side. I'm going to go ahead and make my graph here, and you might want to put this on the right side so that way you have some room. And I'm only going to make the first coordinate system, okay? So I have this graph here. And then I'm going to just label some points. So let's say we have a point here. I'm going to let this be point A. Point A. And point A, its location is x1, y1. So I'm going to go ahead and draw this on the graph. So I have down here, this is going to be my x1. And then the vertical point, my y1. And then I'm going to go ahead and draw another point. So I'm going to put a point way up here. So I have points here, same thing, I'm going to label it point B, and this is going to be x2, y2. And then I'll go ahead and label them on my graph as well. I kind of probably should have made my graph a little longer apparently. So this is x2, and then this up here, y2. And what we want to do is we want to find the midpoint between points A and B. So we have a line here, and we're looking for this midpoint. So this midpoint's somewhere in here. Now mine's not probably exact. Yours you can make exact if you want to, but we're going to try to find this point. So if the midpoint is the average, so let's go back and look at this. The midpoint is the average of the x coordinates and the average of the y coordinates. So if I take these and I'm averaging them, then this point M should then equal the averages of the x. So I'm x2 plus x1 divided by 2, because I want the average, comma, so that's my x coordinate, y2 minus y1 divided by 2, or sorry, plus y1, and that's my y coordinate. So I've added up my x's divided by 2 to get the halfway point, added up my y's divided by 2 to get my halfway point. Therefore, I now have created my midpoint formula. So mine's kind of in the way, but that's okay. So I'm going to move it a little bit, and my midpoint equals what I've just created here. So midpoint equals x2 plus x1 divided by 2, comma, y2 plus y1 divided by 2. We're going to go ahead and do our example 3. The endpoints of line segment RS, R being 1, negative 3, and then S being 4, 2. Find the coordinates of the midpoint. So I'm going to go ahead and graph this first, and then we'll work from that point. This one we're going to need a couple things. First of all, we need a y in the negative, and it has to go all the way down to a negative 3. So keep that in mind. And then all of our x's are positive, so that's nice. So I'm going to graph this. Because my x's are positive, I'm going to graph this way. I'm going to make my scale a little bit smaller, so I need to go out in the x direction 4. So 1, 2, 3, 4. And then that's 4, 2. So 1, 2. So then I have a point up here approximately, which this is point S, 4, 2. And then I need another point, point R, so I have 1, negative 3, 1, 2, 3. So that point's down here somewhere, R, 1, negative 3. This will be a little easier for you to draw than for me to. A little bit difficult to actually draw these points on my thing. So now I'm going to go ahead and use the midpoint formula to find the midpoint. So I know the midpoint, what we just talked about earlier, midpoint, and you have this, and we'll just go ahead and plug it in as opposed to writing it. Sorry, you're going to have to, I drew that without wanting to. So you have the midpoint formula here, so we're just going to go and plug it in since it's right there. So we have the midpoint equals x2, in this case my second point, so I'm going to let this be the number 1's. This is my number 1 point, and this is my second point for this purpose. It really doesn't matter which order you do it in, it's going to work out. So in this case we have x2, so in this case the 4, so I get 4 plus x1 plus this 1, divide that by 2, comma, y2, which is this 2, plus y1, which is a negative 3, divided by 2. Therefore, my midpoint equals 4 plus 1, which is 5. 5 divided by 2 is 5 over 2. We'll leave that as a mixed fraction for now. And then my other one, 2 plus a negative 3 equals negative 1. Negative 1 divided by 2 equals negative half. So my midpoint, and if I rewrite this mixed fraction into a form we can use, it would be 2 1/2. My midpoint lies at 2 1/2 on the x, so 1, 2, and then a half, so somewhere along this point, and then a negative half, so we're going to move down a little bit. So my midpoint is actually down here just a tad. Probably could do a better job of that, so let's do over 2 1/2, and then down into the negative 1/2, somewhere in there. And if we look at that segment that I should create and not overlap, that seems about right to me for the midpoint. And the last thing, using the midpoint, we want to find the end point of this. So I'm going to go ahead and graph this again. We have 2, 1 and 1, 4. So just looking at where we're going, we're probably going to be going down. So my graph is going to look like this again. So that way I can plot these points. M is at 2, 1, so we'll go ahead and draw that in. 1, 2, and then 1. So my M is here. And M is the midpoint of our line JK. J is at 1, 4, so X in the 1 and then 4 in the Y. So J is here. Okay, 1, 4. J, 1, 4. Okay, and then we know the midpoint. We want to find where this is going to end up. So we have another point somewhere in this region based on the graph that we have. So we're going to use the midpoint formula to solve this. So specifically we're going to use parts of it. So we know that the x coordinate, let me get my thing, we know that x equals, in this case, x2 plus x1 over 2. And this x, the midpoint of the x, is what we're looking at. So that midpoint of the x is going to be represented here by 2. So we're going to plug in, so 2 equals, and then x2, we'll say this is x1 up here. And then we're looking for x2. So we got 2, I'm not sure what this was from. 2 equals x2, which is 1, or sorry, x1, which is 1, and then x2, which is what we're going to leave blank. So we have x2 plus 1 divided by 2. Now, whenever we do this, you got to be careful because you have to follow order of operations. I want to move this 2 out of the bottom. So to undo division, I'm going to multiply by 2. If I multiply each side by 2, I get 4 equals x subscript 2 plus 1. I have 1 on the one side. I want to get rid of it or move it to the other side. So I'm going to minus 1 on each side. And therefore, I have 4 minus 1, which is 3. So my x2 equals 3. Now I'm going to do the same thing with the other side. And I'm going to do that with my y. So we'll look at this. My y equals y2 plus y1 divided by 2. My y for my midpoint, which is this 1 here. So I have 1 equals y2, which is what we're trying to find. So we have x2, y2 down here, y1 up here. My y1 is 4. My y2 is what I'm searching for, so y2 plus 4 divided by 2. I want to move that multiplication to the top first. Whatever I do to one side, I must do to the other side. So now I get 2. So 2 times 1 is 2 equals y2 plus 4. Move my 4 to the other side. So minus 4, thought I moved it. Minus 4 on each side. Plus 4 minus 4 equals 0. And then negative 4 plus 2 equals a negative 2. So I get negative 2 equals y2. And if we go back and we look at this, so we go back to my graph, highlight this, my y said, or my x was 3, and my graph isn't very good, so my line is a little off. My line should actually come to that point, which actually looks good, but where I drew it is bad. And then negative 2, 1, 2, I'm probably a little bit high on that. But the math works. The other stuff doesn't. The graph doesn't represent it as well.